Next, we have gradient. Gradient of y equal to m equal to dy dx. Example, find the gradient of the curve y equal to x squared plus 7x minus 2 at the point 2, 16. Gradient is dy dx. So we have y equal to x squared plus 7x minus 2. So differentiate y, dy dx. Differentiate x squared, we have 2x, 7x is 7, and differentiate negative 2, we have 0. So gradient is 2x plus 7. And then at point 2, 16, dy dx equal to 2x is 2 plus 7. So 4 plus 7 is 11. Therefore, the gradient of the curve y equal to x squared plus 7x minus 2 at point 2, 16 is 11. Second example, find the points on the curve y equal to x cubed minus 6x minus 10 where gradient is negative 3. So in this case, question given us the gradient, which is dy dx is the gradient equal to negative 3. Differentiate y, we have dy dx equal to 3x squared minus 6. And we know that dy dx equal negative 3, so 3x squared minus 6 equal to negative 3. 3x squared minus 3 equal to 0. X squared minus 1 equal to 0. X plus 1, x minus 1 equal to 0. So x equal negative 1 and 1. When x equal to negative 1, y equal to negative 1 cubed minus 6 times negative 1 minus 10 equal to negative 5. And when x equal to 1, y equal to 1 cubed minus 6 times 1 minus 10 equal to negative 15. Therefore, the points are negative 1, negative 5, and 1, negative 15.
Stationary points are also called as critical points or turning points. It is a point on the curve y equals to fx when the first derivative or the dy dx equals to 0. There are two types of stationary point, the local maximum point and the local minimum point. There are two methods to determine the type of stationary points, which are the first derivative test and the second derivative test. In this video, we will use first derivative test to determine the extremum point. In this test, we evaluate dy dx on both sides of stationary point. If dy dx is negative on the left of the point and positive on the right of the point, then it is a minimum point. If dy dx is positive on the left side of the point and negative on the right, then it is a maximum point. In this question, we want to find the stationary points. So find dy dx first. Since stationary point is a point when dy dx is equals to 0, so substitute with the dy dx just now. Factorize it, then solve for x. These values of x are also called as critical numbers. Then find the value of y for each value of x. And then state the answer. In this example, we want to find stationary point and determine whether it is a maximum or minimum point by using first derivative test. We find the first derivative first, then equate it with 0 to find the value of x. After that, find the y value by substitute x equals to 2 into the equation and state the stationary point. Now use first derivative test to determine whether it is a maximum or minimum point. Since there is only one point, so we create a 3 rows, 4 columns table. The first column always filled with x, dydx, and slope, where x is the test value and dydx represents the sign plus or minus when we substitute the test value. Then fill the third column with the critical number, where the dydx is equals to 0. Then we test on both sides of x equals to 2. On the left side, we choose 1 to substitute into the dydx and we get negative 2. But we only write negative in the table. Then on the right side, choose 3 to substitute into the dydx and we get positive 2. So the sign is positive. The negative sign means that the slope is negative, so the line is decreasing. Dydx equals to 0 means that it is a horizontal line. And positive sign means the slope is positive, so the line is increasing. From the shape of these lines, we can conclude that 2, 1 is a minimum point. In this example, we want to find stationary points and determine the nature of the points. The nature here means that whether it is a maximum or minimum point. So find the dydx first, then equate it with 0. This expression can be factorized and solve for value of x. After that, find the values of y by substitute x equals to 0 and x equals to 4 into the equation. And state the stationary points. We use first derivative test to determine the nature. This time, create a 3 rows, 6 column table because there are 2 critical numbers. Then fill the critical numbers alternately with the empty columns, where their value of dydx is 0. On the left side of 0, we choose negative 1. You can choose any other value, but make sure it is less than 0 because it is on the left side of 0. So substitute negative 1 into the dydx, we get positive 15, so the sign is positive. On the right side of 0, we had to choose value between 0 and 4. So we choose the easiest one to calculate, which is 1. Substitute it into the dydx, we get negative 9, so the sign is negative. This negative sign also is the sign on the left side of x equals to 4. On the right side of 4, we choose 5 to substitute into dydx, and the value is positive 15, so the sign of dydx is positive. For the slope, we draw the line based on the sign of dydx. The first one is increasing, horizontal, decreasing, horizontal, and increasing again. From here, we can conclude that 0, 10 is a maximum point and 4, negative 22 is a minimum point. Please submit this exercise before class ended.